Hello, my one viewer. Hello, my one viewer. Um, we start at 20-40 hours, so let's give them like around 6 minutes. Then we start. Okay, I think we can start now. It's like 39 hours. I think we can start. Yeah. So today, the last time we had a stream, we were going through the fine tuning evaluations. Yeah. So we created a fine tuning notebook for CTC models using the Nemo toolkit, and then we tried to fine tune for like one epoch and evaluated the model. Sadly, the model never performed so well. So actually, it never improved the baselines. And yeah, and I told you guys to go add more epochs. I did that myself, but to be honest, it never improved the. It improved the. It improved the. It improved the. Give me a minute. Sorry about that. My one viewer. Anyways, yeah. So like I did that myself, but sadly it never. Okay, it improved the model. Remember the last time we were talking about Jonas. So sadly now Zindi made an update. You cannot see the submission names, but we did an inference of Jonas, which was 0.5138. Then I fine tuned for like 5 more epochs, and it improved slightly to like 0.45. Yeah, 0.45, which is worse than our best best submission. Our best submission came from a baseline, which was like 4412, if I remember correctly. Yeah, 4412. So we are still struggling to beat the baseline score. So what I did during the weekend myself, so this is an initiative for you guys as well. What I did was I decided to retrain the model myself from scratch. Yeah. So here it is. But retraining from scratch requires you to fine tune for like 100 epochs or something, or more than like 50 epochs. So currently I fine tuned for like 20 epochs. The model from scratch. I'm not going to go through this on stream this week, but I'll just show you. So I'm fine tuning the CityNet model. This is the base model, STT model, and I'm fine tuning it for like 20 epochs, and it is running in the normal T4 GPU, and this took like how many hours? Let's see. It took like 5 hours, 6 hours. 6 hours for 20 epochs. Now, do the maths. How many hours will 100 epochs take? That's a long time. Yeah. And you can see like training for 20 epochs. It does not even come close to our baseline. Yeah. So the best, and this time like it is printing the validation score, by the way. The best is 0.71. this is the best validation word error rate, which is not even close to our baseline, which is around 0.30 on the validation set. So we still have a long way to go, like fine-tuning this model for many epochs. Also, so something you can do. Remember, we are saving the models. We are saving the best models. As you can see here, um, restoring states from the checkpoint path. That it is restoring the best model, and that is enabled using this helper function, which saves the best model after each validation step. And I know by now you're asking, how did you write even all this code? Remember the notebook you have been referencing for a very long time on the stream? This right here. I just went and read the notebook and re-implemented it from scratch. You'll face some issues though. If you face some issues, please let me know. Maybe on the YouTube channel, on the Zindi discussions, or send me a WhatsApp if you have my number or my email. But yeah, we are using yeah, we are fine-tuning using the link on the GitHub. I cannot find it now. Let me remember. ASR. ASR fine-tuning. Nemo. GitHub. Yeah, I actually, yeah, I used this notebook. I just went and read it and re-implemented it. And for 20 epochs, 0.71 is not that bad, given that you have to fine-tune it for like 100 epochs. So go through this notebook. This notebook goes through two ways of fine-tuning. So there is character modeling, which implements the ASR character by character, and then you have word modeling, which uses byte pair encoding, which you don't have to like train character by character. So the one I'm using at the moment is the subword modeling, but yeah, using byte pair encoding. And so far 0.71, still not close to the best score yet. Yeah, but maybe in the next week we'll go back to these and then we start fine-tuning from scratch, although this will require a lot of compute, bro, a lot of compute. But like a trick you can do, once you get the best model, I think there's a place where the best models are being saved. Let's see. Yeah, experiments. So you can see this exactly. Now you have the checkpoints, yeah? Find one with a yeah, for example, this with a .nemo, and then copy it, and then every time you do 20 epochs, restore from like checkpoints. So where yeah, here, instead of like calling from pre-trained, go to that saved model, and it's good to like save it in your Google Drive so that you don't lose it when you restart the session or when you disconnect the session. So you can like set this to Nemo ASR the models dot ASR model dot restore from. Yes, restore from, and then restore path. You give you specify the path of your ASR, like the fine-tuned model, and then you continue from there. Now this will mimic you training, and then you train for another 20 epochs, because 6 hours is enough to wait. So if you train for another 20 epochs, 20 plus 20 becomes 40. Well, I've not tried this myself. So I don't know how it will perform though. If it will perform like a full 40 epoch fine-tuning, but I'll try tonight before I sleep, and then I'll update you as we continue with the streams. Yeah, so you can do this. So let me save this folder. Let me save this folder in my Google Drive. So yeah, so that I don't lose this progress. So import schedule, source directory equals to, and then destination directory. Where's my AI today? AI, please help me. Yeah, so destination directory is your parent path. Remember the parent path we have been talking, like we have been initializing every now and then. Parent path, and then yeah, ASR model. You can name it however you want, but for uniformity, let us rename it the same way. And then you just call shuttle copy. AI, please do it for me. AI, stop being lazy. AI, bro. AI, bro. Yeah, and then you can either copy or you can move, whichever makes you happy. But since I'm like disconnecting the session right now, yeah, since I'm disconnecting the session right now, this is not part of the stream. I'll just use move. Yeah. Yeah. So don't worry about this. Don't worry about this. If you get time next week, we'll go back to this fine tuning from scratch. But these are homework for you guys to take initiative and yeah, do it for yourself. Do it for yourself, man. I've just shown you the resource I used. It's this. Go to GitHub, NVIDIA, Nemo, find the ASR CTC language fine tuning, go through it. I cannot explain better than this. It actually has good documentation. So just go find it. Yeah, so it has finished successfully. And now we can find this in our Google Drive, and then we can save and pin revision. Now you can use the .nemo model I showed you to restore from and continue with the fine tuning. Yeah, so this was not part of the stream this week. My main goal was to focus on Wav2Vec. I realized that we don't have like a baseline fine tuning notebook for Wav2Vec, so today we are going to focus on that, making sure before the end of the stream either we finish data preparation on stream, which will take time, so we want to wait for the data preparation. So we'll just create the data preparation notebook on stream, and then maybe tomorrow we get back to training. The data preparation I know will take a lot of time. So, but it won't for me. It won't for me because I already did it myself. Yeah, and now I want to do it on stream. I already did it, so I have the data. Actually, it won't take a lot of time. It won't take a lot of time. Yeah. So how do you call it? You either call it data preparation or we either call it, yeah, we can call it data preparation, just in case you don't finish both the preparation and the training. When you finish both, we'll rename it to like training. Yeah, and now since this has finished successfully, we can disconnect it. Nice. Don't worry about this. Don't worry about it. We're going to go to, okay, this is a homework for you guys. You need to go read the repo yourself, the repo notebook yourself, because they have better explanation than me. And we will, or you wait until you finish the Wav2Vec baseline notebook for fine tuning, and then you get back to Nemo. Yes, but you have to like test how Wav2Vec is performing, because you might be wasting time on Nemo, and Wav2Vec is performing pretty well. The one I don't think I'm going to go through is Whisper. Whisper takes a lot of time, man. It takes a lot of time, but maybe the notebook, people are getting 0.30. I don't know how. But yeah, people are getting 0.30. So maybe it's CRISPR they are using, but you have not tested Wav2Vec yet, except the baselines. Yeah. So today we're going to focus on the Wav2Vec. Welcome my two viewers. Yeah. So what are we going to do? What are our goals? Data preparation. So we first load the data from Hugging Face, and then we prepare it, we process it, and then we create the labels and the input IDs, the labels, however you want to call them, and then we save this data because we don't want to like keep on we don't want to keep on processing it each and every time. And yeah, I think that's the plan. That's the plan. That's the plan. That's the plan. But it won't take a long time because I already downloaded the data. I never started the training yet, but I downloaded the data because I don't want to like do it on stream. It takes a lot of time, bro. A lot of time. Cool. So we first link our Google Drive. I hope the AI will, yeah. And this does not, the data preparation does not require GPU, by the way. Just use the CPU. Training requires a GPU though. Yeah.
Once upon a time, there was a young man that liked to fish. And one day, out of the water, whilst fishing, he caught a big fish. He named that fish Zindi.
Nice. It's mounted. The next thing we want to do is download the data. The dependencies. So remember in our previous streams, the Wav2Vec baseline one, we are facing errors with like audio, returning like a cast, not even a cast issue, but the touch codec issue that required us to install like FFmpeg on our Google Colab, which was stressful. And now I figured the fix. The issue was we needed to use specific versions of touch audio. Yeah, we needed to use specific versions of them, and that fixes it. Imagine. Yeah, and we also okay. Where did I get the fix? Touch codec. Yeah, I feel like it's this one. Yeah. So this guy was also facing the same issue. If you face an issue, maybe go to ChatGPT. If you cannot get an answer from ChatGPT, the next thing is Stack Overflow. If you cannot get an answer on Stack Overflow, go to their GitHub issues. So I came here, and then I saw this. So like for example, this guy is telling us to install datasets, the latest upgrade of the audio dataset, specifically for audio. And yeah, so this requires specific versions of touch, and that's how I fixed the issue. Yeah. So pip install. So it requires touch, if I remember correctly. Not if I remember, I just saw it here. Did they show it here? No, but it requires PyTorch 2.60. Yeah, 2.60. It also requires touch vision. But even if you look like if you look at the current version of touch, it's actually 2.60. Touch dot version. Yeah, you can see it's 2.60. So you don't even actually need this. You need touch audio, um, touch vision. You also need touch audio, 2.60. You need, okay, you need those, you need those. And then you also, like, I've referenced a lot of things from our past streams, and this is the benefits. This is the benefit of like watching all the streams in order. For the word error rate calculation, remember, okay, the two viewers who are on the stream, can you tell me like which library we used for the word error rate calculation the last time? Because you'll need this to compute metrics for the Hugging Face trainer. Yeah, so for those who are, I know like there are some loyal viewers. If you can remember, if you can't remember, let me know. Let me know. Let me know. Let me know. Okay, if you cannot remember, it was Jiwa. You also need evaluate for the metrics, and you also need the updated dataset audio. And no worries, Billy. No worries. No worries. Yeah. So this tag right here, okay, if you don't include that tag, it will be very verbose. So that's why we include it to prevent the verbosity. But still, you have some low level of verbosity to show you that there's some progress, like a progress bar of the downloads. Yeah. Yeah. For example, that. So, well, this is downloading. Now we go to the. Now that is all dependent. That is all the dependencies we need. I hope so. Here we import dependencies. Yeah. So OS, we need a we need a regex. This is for data preprocessing. We need pandas. We need numpy, maybe, I don't know, but yeah. We need torch as well, and then Hugging Face stuff like datasets, import. We need load dataset. We need audio, but then yeah, we need audio. We need, okay, all of this is data preparations for which model? Wav2Vec. Right now we have shifted. This week we'll be dealing with our Wav2Vec. Yeah. So like I've explained like a bit of like Nemo stuff at the start of the stream. Don't worry. After the video ends, I mean after the stream ends, I'll upload it, and then you can go check it out. Yeah. I decided to train from scratch, but in a nutshell, I decided to train it from scratch because the fine tuning of the baselines never helps. In short, yeah, it never. Okay, it improved the Jonas model though, but we couldn't even beat our best baseline, which was 0.4412. So I decided to retrain from scratch. But then retraining from scratch will take like 100 epochs or something for the model to become so good. Actually, this was the notebook. Yeah. So I decided to retrain from scratch, and the resource I used for this is like this GitHub link right here. I'll link it on the charts, but we have been referencing it for a while in our previous stream. Yeah, this is the guide I used, and yeah, I trained it for 20 epochs, but you need to train it for like 100 epochs or something. Yeah, but for the 20 epochs, we got a validation word error rate of like 0.71, and 0.71 is pretty far from our baseline score, which is Okay, the baseline score on the leaderboard is 0.4412, but when you validate it on the validation set, it's like 0.30. So we still have a long way to go. Yeah, and so before I show you guys, before I code this on stream from scratch, yeah, so I've given you guys homework to go like read the GitHub because they explain the concepts much better than me. Plus today I'd planned to since you already have an emo fine tuning baseline that people can just plug in models however they wish, we need to create also for our Wav2Vec model and test if the fine tuning of the Wav2Vec baseline models improve the scores. Then after that we'll decide if we train both models from scratch or not. Yes, that's the nutshell. And now we are preparing data for Wav2Vec. We are preparing data for Wav2Vec now. Yeah, so the installation has ended. We need okay, this processing. I'm not even like using my brain, bro. Like I saw it on the discussion, so yeah, this is what I am using. So if you'll see like the code I'll use is actually the same. We can even copy and paste all of these in our and we did the same. We did the same last in a previous stream, not the last one, but in a previous stream. Yeah. So we can just copy all these. Yeah, and load the data. But now we'll make some modification though. We'll make some modification. We'll copy all these. Not all of them though. We'll make some few modifications. Yeah. So and you can even use AI for the data prep. You don't need like data preparation doesn't need like your brains, bro. Yeah, you don't have to struggle a lot. Yes, and that's it. Oh, and we fixed the casting. I mean, not the casting, the touch codec issue. It was a dependency issue. Yeah, so if you use this installation, it will fix it. The issue was like you have to use specific touch version, although not even touch version was the issue. It was the datasets audio version which was the issue, and we saw the fix here on the GitHub issue. It's not like I came up with it. I just googled. Yeah, I just googled. Yeah. So in this issue, they say you install the latest version of like dataset. Yeah. So okay, all of this you don't need. I just wanted the download config because I never wanted to code it on stream. Yeah, and still you have some. Okay, before you continue, you still have some few imports remaining. So for example, you need to log into a Hugging Face. So from Hugging Face hub, import login. And then what else? Oh yeah, we need our token. Remember how we store secrets on Google Colab? We need user data. Yes. And now the warning stuff to ignore them. Oh, okay, AI, thank you. Nice. Now, before even you load the data, you need to log into a Hugging Face. Hugging Face login. It's pretty easy. So you log in and then you use. Okay, this I've shown you this a couple of times though. You can store your your secrets here. You can see like I have a lot of secrets. OpenAI, Gemini, Hugging Face token, HF token. Yeah, so the HF token is the one I'm interested in. So you say user data, .get, you get your HF token. Yeah, and it asks you to grant access, and you grant access. Yeah. Now, remember, we have said this before in our streams. we never want to repeat the same processing again. So every time you load data from Hugging Face, that takes a lot of time to like load. Don't like, I mean, save it in your Google Drive so that you avoid the downloading issue. Yeah. So how we do this defensively is, if not OS path exists, and then yeah, and you can even like, why are we forgetting? This is crucial for yeah, configuration. Store the configuration here, plus config, and then store the what do I want to store? What do I want to store? What do I want to store? The paths, the paths. So dataset path, or train dataset path. Oh, we also need the parent path, by the way. Parent path. No worries, GitHub. No worries, GitHub. No worries, no worries. We are still starting though. We are still starting. Actually, you know what? This we can do, like, I mean, although let me share it live. Let me share the notebook live so that you code with me. You code with me. But yeah, anyone with a link, but I'll make sure it's a viewer so that you don't like interrupt me when I'm, yeah. For the people on the stream, yeah, you can code along with me. I've sent the notebook on the chat. Yeah. So the parent path, obviously, I'm pretty sure you know the jig, how we do it now. So yeah, locate your Google Drive. Yeah, copy these. Train dataset path. Yeah. You also need a couple, and I'll show you why. Or you can, okay, you can do them. You can do them at the same step, but yeah, it depends with you. Kwanza, if you don't have like enough space in your Google Drive, yeah, you don't have to do them separately. Yeah, and now you have train, you have test. Actually, it's not test, but validation. Yeah, validation. Nice. Okay, can you guys confirm, or the people on the stream, can you guys confirm if you got a collab? Nice. Now we are good to go. Cool. Now we have the config now. So if not OS path do exist, thank you. Actually, note the great. Now you can code with me, guys. You can code with me, yeah. Yeah. Let me give you like a 1 minute. I take a quick break. I'll be back. Nice. I'm back now. So we first check if the path exists for the datasets where we want to store the datasets. So for me, I told you guys I already have the data. I don't want to spend most of the time, most of the time like preparing the data, and we did this like a couple of times before. So I already have the data. So mine is not saved like this though. it's saved as processed HF train, and then processed HF validation. Processed HF validation are valid. So if you look at my Google Drive, I actually have the data. I already did this before the stream. Yeah, you can see like I have processed HF train and have processed HF valid, and I also have one with labels. Yeah, so I'll just copy the path. Actually, no, I'll just copy these and add. But this will take a while, like maybe 10 minutes or something if you do it from scratch. Yeah. Nice. I feel like that's it. That's it. Yeah. Sorry for you guys. You'll have to. Okay, if you had downloaded the data, you know what to do. He tuned or like you guys don't have because you never reached here. But this, I'm pretty sure the previous streams we did this. Yeah. So if you have it, just change it to like your where you have stored it. Yeah. So here with train dataset path, if it doesn't exist, do the downloading stuff now. So train, okay, yeah. Actually, you don't need even to like, you don't need to create them because you're saving it using. You'll see why. So we are saving to disk using Hugging Face. So load dataset. We actually need that. Save to disk. Is it from datasets or Hugging Face? Let's see. Come on, save to disk, bro. Cannot import from, yeah. I bet it's from like save to disk. No, it's a method. Yeah, it's a method. What we want is like load from disk. Load from disk. Yeah, this is after you have saved it. But we'll see. Yeah, it's a method. So load dataset. AI, do something for us. Can you do something for us, AI, please? Nothing. Okay. We also need the dataset path here. The Mozilla one. You also need the target language. This we have done it in the previous stream as well. So the dataset name is Mozilla Common Voice. Yeah. Nice. So cfg.dataset path and yeah, where is that again? Nice. So you can see we have the path, we have the config as well. Config is the target language. So specify in the target language. The split, I showed you guys how to find the splits. I'm not going to repeat. Features, download config. Yeah. I feel like that's it. And yeah, the last thing is trust remote code. Remember why we do this? It's also in the previous streams. Yeah, if it doesn't exist, download, then save it to disk. Yeah, it's a method. And then or else, now we use the load from disk. Yes, and you do the same for validation. I bet now the AI will do the right thing now. Nice. So for me, okay, actually this you also need to change it to 16,000, and you know why? We have said this on the previous streams as well. But you can leave it, I don't know if you can leave it at 48,000, but Wav2Vec models are fine-tuned or pre-trained using 16,000 kilohertz. Not 16,000 kilohertz, but 16,000 hertz. Yeah. Yeah. I just hope it doesn't download. Oh, we actually don't need this because you're trusting remote code. This from, yeah, we're good now. I just hope it doesn't download again because I have the data already. Yeah, and you can actually validate if it's being loaded correctly. Nice. I'll give it some time. Cool. The next thing we want to do is create helper functions to clean the data, specifically the sentences. Nice. So if you look at the train dataset, you'll see 46,000 rows. So good luck with downloading, but it won't take long. It will take like around 10 minutes for you guys. Yeah. So we want to check the sentences. We want to preprocess the sentences by removing things like special characters. For the first five, they are not like special characters, but some they do. And also we want to lowercase everything as well. So here we use the re and the regex we imported up above. So create a pattern which uses regex.compile r AI do something for me. AI please. Okay, I'll do it myself. Yeah, AI do something for me, man. Remove special characters. Text in a batch. Remember, this is a Hugging Face dataset, not a pandas data frame. And then it takes in the target column which you want to clean, which is sentence. This right here. Yeah, I feel like now AI should do it for me, man. Like AI, what's wrong, Gemini? Yeah, do it for me, man. Batch. Oh. Gemini, come on. S plus. Nice. You also need to like lower and strip the white cases. Okay, not there, but this should come after. Am I doing the right thing there? So using re and regex to clean the data. Okay. Let me return batch. Now you're working. Come on, I don't want to struggle, man. Even, yeah, thank you. And to improve the speed, actually, we can use batch is equals to true, and then maybe specify the batch size, but it's not. I don't think it's a must. If you do, yeah. So if you have done everything correctly. So for those who are joining late, I shared the notebook on the stream. if you want to code with me, just click on the notebook, and I think you will be here with me though. But you won't have the data. You have to download the data. I already had the data. I downloaded before stream because it takes a lot of time, man. Actually, this is not even the part that takes a lot of time. At Jafika Apple, when you get there, yeah. You will realize, yeah. Anyways, that is the cleaning we wanted to do. Now we have to prepare data in a way that trainer expects. Yeah, so we include things like input IDs, input values, input lengths for the data loader to like data collector to like batch the audios. Okay, for those guys who are joining right now, have you seen the notebook? I've shared this kind of notebook that I'm coding live. Yeah, so that you guys like code with me. Can someone confirm? One of you guys. Not the ones who are here, not Gitao and Nimfree and Billy, the others who have joined right now. Can you like type in the chats if you can access the notebook? Okay, can you confirm so that we continue? Okay, I'm waiting for someone to type, bros and girls. Anyways, I'll just continue. Since people are shy to talk on the chats. But now the next thing, like when I say prepare data in a way that a trainer expects, it's not like the trainer, but oh, I see. But I can see like 5 viewers, so there are like 2 more. But anyways, no pressure. So when I say prepare data, that's that the model expects. I mean, like you cannot like fine tune the model in the raw audio files. You need to convert them into numeric features, right? So we need to create a function that takes in an audio file and the sentence. Remember the sentence we have just cleaned up here, and turn them into exact numeric features and labels. Numeric features and labels our ASR model needs. Now the Wav2Vec model, and feed this to the trainer now for the training phase. Yeah, so that is what we mean by the prepare data in a way the model expects. So define prepare and we do it batch by batch. So it takes in batch, it takes in a processor. This processor we are going to talk about it later, but it's just the model processor anyways. It takes in the target call, which is sentence. Once you do this, okay, now this is the function which takes a lot of time to process the data set. But once we finish this, everything will be okay for training now. It creates speech, which actually is audio. So this audio, it's this right here. And the audio contains an array. I don't want to print it because it takes a lot of time to like even visualize one. But we can actually before we finish coding these functions. Train dataset audio 0, or it's like the other way around. It's not like pandas. Specify the index first and then print the audio. Yeah, this will take a while before it finishes, but anyways, we are still like coding this function. AI, please do it for me. AI, please. Jackson, I also need to create a, it's not like creating because even the sampling rate is there. You just like access it from the audio. And then the next thing, now you process the audio into model inputs. Now the numeric features and labels. But first the numeric features. So inputs is equals to processor. You use the processor. The processor, I'm going to talk about it, but it's just a model, yeah? Yeah, AI, thank you. So speech, sampling rates, return tenses, padding is equals to true. Yeah, that's correct. Batch input values, batch, okay. Input of values also need to store the input lengths. This will be used by the data collector later. Yeah. And then we create the labels. Tokenize the targets text with processors, target processor. Thank you, AI. Nice. So as this finished, yeah, you can see like the array, we just get it from the audio because you already like casted it here. Remember when you are loading, yeah, we already did this. So instead it gives us the, not compared to the previous times where it was giving us bytes. Today it's giving us array, the array itself, and the sampling rate. When it gives you bytes, it means you have to reprocess it again using like an extra library, for example, sound file or Librosa or something. Yeah, and that's why we had to like fix the bug of the touch codec bug. It wasn't even a bug; it was a dependency issue. Yeah, and now we have the function. So this creates the numeric features and the labels. And now the processor it's, yeah, load processor. So if you come to, remember the baseline we used for my Hugging Face. Let's see. Excel SR files. Which do you use? The best was not mine. The best was Alamshar. If you remember correctly. The best was this. So this is the baseline we want to start from. So let's use this. Model name is equals to Alamshar. Yeah, this was the model which gave us 0.5587. So our expectation is when you start from this baseline, we don't have to like get a score greater than 0.55. We should get better scores. Now maybe 0.40 to match the Nemo one. So model name. Yes. Cool. And then we load the processor. So we use, did you even load the okay, you never did. But yeah, from transformers import auto processor. Nice. Now you have the auto processor. So processor is equals to auto processor that from pre-trained, and then you specify the model. Wait, why is it loading this much, man? Now here is where it will take ages to run. This will take it will take a lot of time to run. Yeah, it will take let me prepare you, the people who are coding with me on stream. This part will take a lot of time. Yeah. So also defensive programming. Okay, it's not defensive programming, but you just don't want to like you want to defend yourself from reprocessing because it takes a lot of time. Remember now the process test path is specified here. For example, this now with labels. Now this stores the data with labels. So you can actually do all this at a go, and then instead of like saving it partially, for example, they downloaded from Hugging Face, and then you store also the processed one, taking up much space. You can just store the processed one. Yeah. But you make sure these are in the same code block to avoid reprocessing. Even downloading takes time. But this is the bottleneck. This right here is the bottleneck. If OS the path that exists, if not OS that exists, AI do something for me. Thank you. So you specify the processor. Yeah. So train dataset dot map. You can use either these or lambda functions. So lambda b prepare batch, and then pass in the batch and the processor. Come on AI, batch is equals to true. No. Hey, that's a lot. That's a lot. Maybe it's okay. We should specify also the batch size here. Maybe depends. Where do you? Yeah, batch size. Batch size is equals to maybe 8, maybe 16. Number of processes, maybe 8 of them. Yeah. So you specify the batch size. Number of processes. Yeah. You can either remove columns. Yeah, you can, because you already have. If you're not storing both of them, maybe you can leave them for further like analysis. But since for me, I'm storing both of them. Yeah, you can remove the columns. The same thing, save to disk. Else load from disk. Yeah. AI. Yeah, you're doing a great job. Hopefully it doesn't. Actually, this takes a lot of time, bro. A lot of time. I don't know if it was only mine, but yeah. Come on, AI. Process validation data path. Dot map. My lambda function. Batch is equals to true. Remove columns. Save to disk. Yeah. So let me run this. Nice. You can see mine is loading from disk because I already have it. I already created it before the stream. Yeah, you can see I have the with labels. Yeah. Hey, because it takes a lot of time, man. You can try it yourself. Oh, so for the people who are coding live on stream, you can tell me how long how long it says here. Imagine loading from this says 30 minutes, but it won't take 30 minutes. Imagine like now preparing it, how long it will take. Bro, it takes a lot of time. Yeah, let's wait for it to load maybe. Yeah, for the people who are coding live on stream, you can let me know how long it's telling you it will take. As it is downloading, let me take a quick water break. Okay, maybe for me it's going to work since I'm on Colab Pro. Yeah, you see, like my disk is like 225 GB. I know maybe, and already 62 has already been consumed. So this data is huge. So if yours, I don't know if the free tier is still 225. I feel it's like 60 or something there about. If you cannot, okay, if yours cannot load, like all of the training data, as do sampling, like maybe say train data set. Was it sample? Like sample, like maybe 20,000 or 20,000. Yeah, let me ask the AI. Sample 20,000 rows from the train dataset and assign it as a train subset. Yeah, because honestly, this consumes a lot of like both both the RAM and the disk, bro. Will it even? I feel like it will crash before you even load like all of it. Yeah. Yeah. Come on, AI, do it for me, man. Nice. Yeah, something like that. Select like 20,000. If 20,000 is still like a lot, maybe 15,000. I don't know. Experiment with the number. Experiment with the number. Yeah. Yeah. You got. So I've commented it out, but you can try it because I doubt if the free tier gives people more than 100 GB. Yeah. Mine is because I'm on Colab Pro, despite the fact that I'm on CPU. Um, yeah, I'm still on CPU. Plus, on your own Colab Pro, you can. Yeah, what if disk is 107 GB? Yeah, that you have to sample. That you have to sample. Yeah. Yeah, but we can toggle this and get high RAM as well. But let's see if it will consume all of it. We are still at 67. Maybe it will load it. It will load everything. Yeah, Fritaya has like 100 and yeah, it doesn't have 225. Yeah, so you can sample. You can sample some few. maybe 20,000, because right now we are loading all the 46,000. 46,000 is a lot. Yeah, let's see, but let's see if it will fit. Maybe it will fit. Maybe it will fit. Yeah, maybe it will fit. Maybe. That's a big maybe. It's that is 8% it has already consumed 69. Hey, that's crazy. That's crazy. Imagine now downloading it. Yeah. And remember, this is just the training set. There's also the validation set as well. Yeah, there's also the validation set. Bros, bro, I don't know what you guys are going to do, man. But yeah. Sample. If you're not on the Google Colab Pro, sample. Process them using chunks. Yeah. Oh, and good news for the stream. Good news for the stream. Yeah. I had a problem, but it's not good news because now if I okay, personally I have a PC. Personally I have a PC with a 3090. So there's this competition right here. I wanted to do it on my PC because of yeah, because I had issues with my WSL not running CUDA. Uh, but then this I want to do this on stream, by the way. I want to do this on stream. Maybe the where the accuracy part, the IU polygon, maybe not. Yeah, I just want to do the testing stuff where we use a vision language model. Yeah. So maybe these parts alone. This not really. But then I wanted to use my PC, but then that will disadvantage a lot of people who don't own personal GPUs, which is like 95%, maybe even more. But I'll think about it. I'll think about it. I'll think about it. Yeah. I'll know. I'll know. But now we can run like crazy stuff now on the stream. Yeah. Because I wanna. Hey, because this, bro. Is there anyone who has done this? How are you doing it on Collab? Like, this is crazy. Data size is 18.4 GB, and this is just the zipped file. When you unzip, maybe even more. But yeah. So I wonder how people are doing this on Google Colab. Maybe Colab Pro. Damn, has this been sold? Let's see. Oh yeah, there's also like some caveats. For example, you have to train in a centralized format, federated format. To be honest, I don't know anything about this. I haven't even looked at the data yet. I'm planning to download because this data is a lot. My internet speed is around like 30 Mbps. So I want to leave it downloading over the night. Yeah, and maybe start working on it because now I can see the time is going. Uh, yeah, it's closing on 15th September, and today we are 12, so almost 30 days. And the data is huge, so like maybe every day you do one experiment. So that means 30 experiments per day if you're going to work even weekends. Uh, yeah, but you also have to pay attention to this. So centralized format, federated format, bro, I have no idea what these are. I'll have to read more. A centralized model trained using the combined dataset, a federated learning approach trained using the split dataset. But why are people getting like good scores? Why are people getting good scores? Like this is even so good, bro. Like it's almost perfect. It's almost perfect. Oh, Nimfree, can you tell us? Can you tell us? Why do you think people? I know Nimfree is on the stream. Why are people getting good scores? Like this is almost perfect, bro. Like, and how did you even process the huge data? Give us some tips. Give us some tips. Guitar already gave us tips to handle the Barbados one, and I've actually looked at, looked at some of the data. Maybe at the end of this. Okay, let's go back to the stream. 84.7. Okay, it's still loading. Imagine this is loading from this. Now imagine downloading. Yeah, I think I'm not going to do the training today. I'm going to like wait until everyone. Okay, not everyone. The people doing the stream. Guitar as always. Yeah, and who calls with me. So I'm going to wait for you guys. I'm going to like save this as data preparation. You already have the notebook. Um, you run it over the night. By tomorrow you'll have the data. If like you find issues with like disk issues or or RAM issues, just sample the data and comment this and sample it, and then because these two blocks, actually this is not a problem. Validation is like 12,000, so this will run very fast. But this 46K, yeah, it will take a while. So I'm going to like wait until everyone has the data. Yeah, Guitar, yeah. Make sure you run overnights. Then tomorrow we go embark on training. Training is actually so simple. What we are left with, if you go to my GitHub, is just setting up the data collator. Yeah, and then setting up trainer and running the training. Yeah, so like tomorrow I want to be a very long one as well. Maybe we'll start like, okay, maybe we'll discuss a bit of Barbados, but I don't want to like I don't want to like mix streams, yeah. So the remaining part is actually pretty simple. Setup. Okay, this will not load. The remaining part is actually pretty simple. Set up the data collector. Yeah, you see. Yeah, this is what is remaining. You can just imagine, you can like if you finish the data preparation before the stream tomorrow, just go copy and paste. I'm going to explain this more on tomorrow's stream. I mean, I can even explain now. The data collector is not like a complex. It's not like a complex issue, but what data collection is in essence is it takes in, you know, like each target sentence, each audio, I mean the sequences created from this step here, they are variable. It's not like, for example, the sentence can be 29 length of 29 words, another one 25, another one 10, etc. So data collection in essence, it pads them to them either the maximum length per batch, or the maximum length you specify. So if you specify a maximum length of 228, the shorter ones, for example the 25 length, will be padded with zeros. Yeah, so that you create the same size, like you make sure each batch has the same size. Yeah, that's the simplest way I can explain the data collection part. Yeah, so it's not like a hard thing. You may see a lot of code, but it's not like a hard thing. Okay, this right here is to compute the metrics. Remember the evaluate we loaded up there, the zero, so we calculate the word error rate, and then forget about this. We have already done all this, so don't follow the GitHub one. Yeah, we load the model. All this we are going to do tomorrow. I set up the data collector, set up the trainer, and then you train, and then you see your word error rates reducing, hopefully. Hopefully. Remember, the number one never improved. Yeah. But anyways, I'm just gonna leave this running. I feel like we still have like 5 minutes. Yeah. Maybe let me see if I can share one. But yeah, today I started looking at the Barbados data for the first time today. It's actually pretty interesting. This is a competition I wanna do on stream. Hopefully, the VLLM part though. Let me see if I can add my file manager to the stream. But I don't want you to see my my secret projects that I'm working on. But anyway, let me. Um, 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 oh, so it has finished. It has finished. But this has an error. I don't know why. The model corresponding to this feature extractor was trained using. Wait. We're not even using the model, are we? Processor. What's going on? Was trained using a sampling rate of 1600. 16,000. Please make sure that the provided raw speech input or sampled with 16,000 are not. Bro, they're all 16,000. What do you mean, man? By the way, I'll just delete it on my Google Drive. Do it right now. Yeah. Delete it. Validation is label. Okay, this I don't have a problem deleting this because it's not like so huge, and you'll see that actually it's a good thing to see the download speeds. So we are going to do something here. I mean, force remount. Nice. Yeah, and then reprocess this. Maybe it was the reprocessing. Maybe. I don't know. Oh yeah, the disk 98. Yeah, I don't think the printer will be able to sustain. What do you mean, bro? Please make sure that I see. Do I? I mean, we are sampling it at 16K. I don't know why this is giving an error. But sampling rate, we can try setting this to like 16K and see if it works or not. Yeah, I don't know why this is it's leading to an error. Maybe it's how we saved the original validation data, but the validation data is not like that. It's not like, yeah, we can delete it and re-download it again. It's not that huge. Move to bin, empty. Turns out we're not going to like check the Barbados one. Sorry, guys. Time is running out and we are facing bugs. Yeah, post remount it again. But the validation doesn't take a lot of time. Yeah, it doesn't take a lot of time. Let's actually process it in a new cell. Split validation features, trust remote code, save to, yeah, yeah. Yeah, this doesn't take a lot of time to be honest. Yeah, it doesn't take a lot of time. But anyways, thank you guys for joining the stream. Uh, See ya tomorrow when we do the fun part. Yeah, the training when we do the training now. Yeah, thank you always for showing support, both the people who join the stream and the people on YouTube. Um, yeah, continue supporting the boy. Do you know, honestly, YouTube we are making progress, a lot of progress. Uh, 157 subscribers. That's a massive win. Our goal is 200 before which month are we in? August ends. Yeah, before August ends, hopefully, God willing. Yeah. Uh, yeah. So I'll end the stream now. I feel like this will be solved once you re-download the data. So when you get the people in the stream have access to the notebook. So let me when I save and pin revision, just go just re-access the notebook or refresh your notebook. Refresh your notebook. You'll see the new changes. Yeah, you'll see the new changes that you don't have. Tomorrow we will go and train our model. I'm using the data we have created. Okay, guys. Thank you for showing love. Uh, Adios, and convince your friends to be joining or follow me on YouTube if you haven't yet. Yeah, thank you guys. Bye.